Hello everyone, welcome back again in chapter 4 fluid. Now we continue our lesson under subtopic 4.9, which is viscosity and Poiseuille's law. Okay, before we start, let's introduce some mechanism related to this subtopic. Okay, if you look into this diagram, okay, different solution they have different viscosity level. So for example, between three solution, water, okay, oil and honey, okay, oil, honey. So honey and oil have a high viscosity than water. So it means a real fluid have some internal friction. Okay, this both solution has internal friction. This is what we call viscosity. The viscosity can be measured using this equation, using Newton's law of viscosity, which is F force equal to coefficient of viscosity multiplied with A, area, multiplied with V, velocity, divided with length. So if you look into this diagram, okay, so fluid is flowed in a capillary or pipe, okay, they have diameter or length with at a certain velocity, okay, towards, okay, F force, okay. So the rate of flow in fluid in a round tubes depends on the viscosity of the fluid, okay. As I mentioned before, the pressure different and the dimension of the tube, it means the diameter, this denoted as symbol L. The volume flow rate is proportional to the pressure difference, okay. Pressure difference is P2 minus P1 equal to delta P. Inversely proportional to the length, okay, to the length of the tube and to the pressure difference, and proportional to the fourth power of the radius of the tube. So this represented by the Poiseuille's equation. Okay, Q divided with T time, Q is the volumetric flow rate, equal to pi r power of 4. Change of the pressure divided with the at multiply coefficient of viscosity multiply with the size of the capillary or the length. Okay, we go to the next one. The Poiseuille's law. Okay, flow in tube. Okay, let's look this diagram. Okay, diagram A and B. A represent glass tube in water, while B represent glass tube in mercury. So both different solution, they have on viscosity value respectively. So what we can explain from this or both diagram, water molecule are more strongly attracted to glass than they are to each other. As we can see, they stick more higher than the mercury. They did not stick on the tube. Okay, you can see the water is well stick on the wall of the tube. It means this Okay, allow the water to penetrate material more easily lah. Okay, and the last one, for example, another tube is placed in a fluid, the fluid will exhibit capillarity. Okay, this is what I can say just now. Okay, next, we look into the Poiseuille's law in daily life. So, for example, space tension and capillarity, we can see the droplet of water from the rain will stick, okay, onto the tree. Okay, while you can see here mosquito, they stick on the surface of the water. This showing that the solution is a good surface tension, as shown in this picture. And the last slide is the Stokes law. What is that mean by the Stokes law? Stokes law describe the motion of a small spherical object in a viscous fluid. So we can see here, when a body moves through a fluid, it experiences a resistive force. Okay, resistive force means like a body or object, they move through a fluid, okay, experience a resistive force. Resistive force or resisting force is represented by the symbol F. Okay, because of the presence of the fluid. So, resisting force can be calculated using this equation. F equal to 6 multiply pi multiply with the radius of sphere. If the object is sphere, multiply with the radius of sphere, then multiply with the coefficient of viscosity, this viscosity of the fluid or solution, multiply with the velocity of sphere, the fluid movement of fluid. Okay, that's all for our all lesson under topic or chapter 4.0 fluids. Thank you very much. Thank you for your attention.